Okay, here's a very quick run through of our notes for those people who may miss the class day. This will not include everything we talked about in class, but is just here to be able to give you to fill in your notes and get through it very quickly with a bare minimum amount of information. Okay, so we're going to start about what is chemistry. Chemistry is our study of properties and interactions between matter and energy. So we're going to talk about what the properties are, how they interact, and we're going to talk about matter, and we're going to talk about energy. In Unit 1, we're going to have learning targets like we have for all of our units. Be aware of these defining words like inside of here. They tell you how I'm going to assess you on every target. For example, number 4 says I can calculate density. So by saying calculate, that means we are going to actually have to do some calculations there. Okay. So these are all of our targets for our Unit 1. So first of all, what is matter? Okay. If we define matter as anything that has both volume and has mass, okay? So then what isn't matter, okay? So things like energy, things like the void of space, things like sound and light are things that are not matter. So how do we define volume, okay? So we measure volume, the space that the object takes up is our volume. So that's our definition for volume, is the space that an object takes up. And we measure volumes using a graduated cylinder. The units we use are milliliters or centimeters cubed. And can we solve for volume? Yes, it's called a derived unit, which means we can actually solve for it. Like the volume of a rectangular shaped object is length times width times height, for example. Now mass, in contrast, is the amount of matter in an object. We measure mass on electronic balances. We use kilograms or grams as our unit. And we do not actually solve for mass because mass is a base unit, which means it's something that is fundamental. So it doesn't take solving for different lengths to find mass. So that brings us to this idea of what is density. So density is a comparison of how massive something is in comparison to its volume. So it's a ratio between mass and volume. Okay. So looking at density in that idea, the more mass you have in the same volume will be higher density. The less mass you have in the same volume will be lower density. If you flip it, the more volume you have with the same mass is lower density, and less volume in the same mass will be higher density. Okay. So what we say is that mass is directly proportional to density. So as mass goes up, so does density. As mass goes down, so does density. Volume is inverse of density. As volume goes up, density goes down. As volume goes down, density goes up. Here's some different blocks for us to this idea about density investigations. Okay, so if we rank these from low to high density, you'll notice that these are all the same mass, 5, 5, 5, and 5. So that means if they're all the same mass, the ones with the least amount of volume will be the most dense. So this would be, number 1 would be the most dense, then 3, then 4, and 2 would be our least dense thing because it has the most volume with the same mass. Down here, the opposite is true. We have the same volume. A, B, C, and D are all the same size, but their masses are different. So because mass is direct, we look for the heaviest one. So 8 kilograms, that would be the most mass in the same volume. So this would be the most dense. And then this would be next. 4 and 2 would be the least dense of these. When we calculate density, we take mass divided by volume. That's our equation. And then you could rearrange it into 3 different versions. So it could be density is mass divided by volume. But if you're solving for mass, mass is density times volume. If you're solving for volume, it's mass divided by density. Okay. Okay, here are some practice calculations we did in class. So the first one is solving for the density. The second one is solving for the volume. And the third one is solving for the mass. So you notice how we use all 3 equations. The density is mass divided by volume. That volume is mass divided by density. Ooh, that should be a D for density there. I apologize. And the third one is mass is density times volume. So you can look at the equations, see the work, and see the answers that we did in class. The next thing we want to talk about are states of matter. There are 3 main states of matter that we want to talk about: solids, liquids, and gases. And this is how we define them. Okay, so solids have definite volume and shape. They're not compressible. They have the lowest energy and they vibrate only. Liquids have a definite volume, but their shape can change. They cannot be compressed. Their energy is medium and they are able to flow. Gases, their volume can change and their shape can change. You can compress them. They have the most energy and they can move freely. When we look at properties of matter, we want to talk about physical properties versus chemical properties. Okay, so physical properties are things that can be observed without changing the formula or the structure of the chemical. So things like elasticity, color, hardness, those are examples of physical properties. Chemical properties are things that you must observe by changing the chemical. So that's things like how corrosive something is or how flammable something is. If you're doing the notes, you'd have an activity that we would insert here. When we have matter that changes now, that's like the verb or the action. So physical changes are things that happen that don't change its properties, okay? So things like melting, boiling, dissolving, cutting, tearing, breaking are physical changes. Things that are chemical changes are things where the composition must be changed. So like breaking bonds, that kind of stuff, okay? So that's like corroding, electricity, combustion, burning, becoming toxic, that kind of stuff are chemical changes. We have 6 different things that we can say are indicators of a chemical change. We can produce gas, we can make a precipitate, which is a solid, we can have a color change, a temperature change, light can be emitted, and then if we any other really distinct chemical or physical change that we have. Keep in mind that there are some exceptions to these, so the more of these things we see, the better that we can choose that is actually chemistry. Now, when we're classifying our different substances, we have to break it down into different classifications. So we have pure substances first. Pure substances can be broken down into elements, which are the building blocks of our nature, and atoms underneath elements. They're the smallest particle of that element. Compounds and molecules are also considered pure substances because they chemically combine to make a new property, okay? Because of that chemical combination, we do still call them a pure substance because they have their own unique properties and they're held together by those chemical bonds. So see, here we have a picture of a single atom element, here we have a picture of a 2-atom element, and here we have a picture of a compound or molecule. If you're not a pure substance, that means you are a mixture. Here we're just going to be physically mixing things together. In this case, the individual substances keep their own properties and they're only held together by forces between them. We do have 2 types of mixtures. Homogeneous, that means we distribute them evenly. Things like solutions and alloys are your homogeneous mixtures. Solutions are anytime you dissolve something into water. Alloys are when you blend 2 or more metals together to make a new thing, like brass or bronze or stainless steel. Heterogeneous mixtures are uneven distribution. So anytime we blend things together that is not evenly distributed, that would be heterogeneous. So here, these are all examples of different mixtures. We can't really distinguish between homogeneous and heterogeneous here because they're too small of a sample size. Here's a breakdown of our classifications. All matter can either be a pure substance or a mixture. Then if you're pure, you're a compound or element, or you're heterogeneous or homogeneous.